the homeschool chemist, and today's example problem is asking us to find the change in enthalpy of a reaction given the amount of kilograms of two reactants. So we're going to have to find a limiting reactant here. So all the pertinent information is underlined. We have a reaction underlined in green. We have our amounts of each reactant underlined in orange, as well as the enthalpy of reaction for 1 mole. So the first step we need to do is find the limiting reactant. So we are told that we have 0.608 kilograms of magnesium. So now we know that 1 kilogram is equal to 1,000 grams. And we know from the periodic table that 24.31 grams of magnesium is equal to 1 mole of magnesium. So if we multiply that through, we find we have 25.01 moles of magnesium. Now we need to find out how many moles of silicon tetrafluoride we have. So we have 2.3 kilograms of SiCl4. And again, we know that 1 kilogram is equal to 1,000 grams. And now if we add up the molar mass of silicon tetrafluoride, we find that it is 169.85 grams per mole. If we multiply that through, we find that we have 13.54 moles of SiCl4. So now, to find which one is limiting. So in the chemical equation we're given, we see that we need 2 moles of magnesium for every 1 mole of silicon tetrachloride. So if we take, using that, we take 25.01 moles of magnesium over 13.54 moles of silicon tetrachloride. If the ratio for silicon tetrafluoride and magnesium were perfect, it would equal 2. If it was greater than 2, we would find that the magnesium was in excess. But as it turns out, 25.01 divided by 13.54 is 1.85, which means that magnesium is limiting in this reaction. So now that we've found out what is the limiting reactant, we need to find out how, with this amount of magnesium we have, how many moles of silicon tetrafluoride do we need to do this reaction. So the next step is going to be 25.01 moles of magnesium and 2 magnesiums for every 1 SiCl4, and we find that we're going to need 12.505 moles of SiCl4. And that will use up all of our magnesium. So the reason we found the number of moles of SiCl4 we need is because the delta H for this reaction is in regards to the conversion of SiCl4 to pure silicon, not magnesium. I know it doesn't say that, but that's what this delta H is for. So now that we know how many moles of SiCl4 are required to use up all the magnesium, all we do is take 12.505 moles of SiCl4 and we can multiply by the enthalpy, which is given to us and is negative 625 kilojoules per mole. Now, we're able to multiply that. Now this is kilojoules per mole, and this is the number of moles of silicon tetrachloride. So the overall enthalpy is going to be the molar enthalpy times the number of moles. So 12.505 times negative 625 is going to be negative 7815 kilojoules. And that is going to be your answer for this problem. That is the total enthalpy of reaction given the amount of reactants we have.